With your partner, you're going to look at these XY tables. And what you're going to do is describe what is happening in words. So really what I want you to do is put it in context. All right? Look at your variables. Look what they are. Don't just explain the math, but in context, what's going on here. So who's got an idea? Who can put in context what's going on with table A? Sean?
For every one lap, that's 400 meters ran.
Yeah, each lap is 400 meters. So I saw like a lot of equations out there and stuff, but all we need right here, describing words, what's happening. Each lap is 400 meters. But guys, we've been lied to. I Googled this junk today. I thought 4 laps was a mile, right? A quarter mile is 402 meters. So you'd have to run an additional 8 meters on the track. We've been lied to, friends. That is not a quarter mile track. It is almost a quarter mile. Oh, you're saying you're going to run hard through the end and then kind of jog for a second? So maybe you'll still get it. Yeah, but they're not timing it. I'm going to tell Putnam. They say next time you guys do the mile, you call it the 1600 in track, but you call it running the mile in PE, don't you? Oh, man. Anyway, that's just something I thought about today, and I Googled it. My whole life's been a lie, pretty much, is what that says. But, Table B. What's happening in Table B? What's the context? Table B, what's happening? What's the context? Ivy? Okay.
The distance from home is getting greater, and the distance from school is getting smaller.
So something like walking from home to school. I like that. And then I would rephrase what you said as each mile further from home is a mile closer to school. Something like that is what you're saying?
So, yeah.
And what's the sum of the miles always equaling?
Meters.
Or meters, sorry. Each meter. What are they always equaling?
That'd be a long 400 miles.
400 total meters, because even if you're like halfway, right, you're 200 from each thing. Okay, so that's important. That's why this is called something about 400. So at these last 2 tables, you got to try to put your adult hat on. Think like an adult would, okay? This has to deal with like adulty stuff. So friends, while you might be able to find the mathematical relationship on these, the context might be tougher, so stay with me, all right? So for Table C, who can tell me what's going on Table C? What's your idea? I'm going to start picking random people because I have some very generous volunteers that volunteer every time. Vinny.
So in Table C, we found just a relationship.
Okay, what'd you find?
We found that when the total expenses goes up, the amount or the electricity goes up, the total expenses go up.
Okay, how much are they going up by?
I got that too. 400.
It looks like it's always plus 400.
I put myself out there. That's what I had.
Okay?
It just
So, in words, we have electricity plus 400 in other expenses.
wow.
Right? That'd be like in words what's happening. What might those other expenses be? If we're talking, electricity is one of these things. Sophia?
Water bill?
Yeah, water bill. Cable.
Maybe the
Gas.
gas. Yeah.
Heating?
Gas. Well, heating would be gas or electric. Or maybe like LP if you didn't live in the city. Air conditioning is going to be only electric. Or, other things. So things that are kind of like bills. Now, one thing is, this is the first time someone said cable.
Yeah, the water bill probably.
And I think cable might be one of the best things because this is exactly 400 every time. And I think, from my experience, gas and water are variable. It depends on how much you use.
Yeah.
So I really like cable bill, maybe phone bill.
I actually don't like any bill.
Those are like the same. Those are the same like each month regardless, as long as you have like unlimited plan, I guess. So yeah, those are things to consider. But it looks like Electricity plus $400 in other expenses. What about table D? We have a monthly salary and then amount deposited in dollars. What's happening there, Meredith?
Huh?
1 second. Taxes. So what happens is when you get paid, it shows up. It's almost everybody now is called direct deposit. So that's where this deposited is. It shows up in your checking account. But I'll let you know, whole salaries don't show up in checking accounts. So where is it going? Well, how much is disappearing each time here? 400. So there's 400
So pretty much the monthly salary.
going to, where's it going though? So we'll put this in real account. I saw Meredith write something down, that's why I called on Meredith. You're keeping 400 and you're depositing the rest, right? So
40%.
well, no, you're depositing all this, 400 is going away.
Well, then that 400.
This is the amount in your account. The 400 is not there. So what's happening though? What is that $400? Because it's going somewhere.
Just like anything.
Yeah, well, kind of, but it's not showing up. No, not shopping, because that's got to be in your checking account to spend it.
It's going to.
Not to savings, because that's getting deposited. That's what's showing up. It could be a college fund. It could be a Michigan
vacation trip.
529 coming out. It could be a vacation, because to spend money on vacation, you need that money in your account.
Yeah, but
This is money disappearing from money you earned to money you get in your account. So where's it going? Meredith, I called you because I saw it on your paper.
probably on your paper. Taxes takes 40%.
Meredith, what's some of this money that's disappearing?
It's going to taxes.
Taxes is definitely a chunk. State, federal, or if you're me, city income tax, since I live in Grand Rapids. Okay. Where else could it be going? So we got college savings. That comes out of
Ooh, I
mine.
got one.
Taxes. Vinny, what do you think?
Medical bills.
Okay, kind of. We can say HSA, a health savings account.
Culture.
Like you earn it, but then some of it goes away in these things before it gets deposited in your account. All right? Make sense?
Yeah.
That's a hard one for context because you probably aren't looking at page stubs. That's why I told you some of my experience. With your partner, match the equations to the correct table. Table A, B, C, or D. Help me match these up. Equation 1, 400 plus x equals y. Which one you thinking? Try to put it up on a hand. People think C. I also say C. That's that electricity. C. Okay? See what I did there? Nobody got it? Electricity. Because it's a different letter than T. Okay. Equation 2. Which one were we taking $400 off, Ryan? D, those taxes and junk. We're losing $400 out the gate before it even gets in our account. All right, equation 3. The sum is $400, Ava. B, that's the walk-in to and from school, right? School home distance. And then 400 times X. A. That's just a misprint thing. All right, there they are. Here's a new table. This is situational. I'd read the words. I want you to come up with an equation for this one. What is the relationship? I want it as an equation. I've got parallelograms and I've got bases and heights. So what's true about parallelograms and their base and height? Elsa?
48 divided by base equals height.
Okay, I don't hate that. All right, I saw it a different way, but the same way. Rap, what are you thinking?
Base times height equals 48 versus.
Yeah, that's kind of the one I saw. They're the same thing, though. You could also say that the base is equal to 48 divided by the height.
Yep, that makes sense.
All right, base times height. So what this is all of these parallelograms have what? An area of 48 square inches. All the combinations of whole numbers, I guess. You could have decimals and fractions work out too. Oh, there'd be more. So for number 2, this is what I heard as I was listening around. Most people had something like 300 divided by the number of people that win would equal how much they would each get. Or you could also say how much each got times the number of people would total 300. These would be the same. Okay, and then number 3, I saw someone organize it a way that I liked more than I organized it, so I'm going to show you what they did. They did something like gallons, cups, and ounces, and they made like a 3-column table, and I really liked it. And what they did is they said something like a half gallon is 8 cups, and they said 32 ounces is 4 cups, and then they filled these out. So like 4 to 8's half, so a half gallon would have to be 16 ounces. Half of 1/2 is a 1/4, so that was a 1/4 right there. But really we want 1 gallon, right? So 1 gallon would be how many cups? 16, which would be how many ounces? I didn't get 32. To get from 1/2 to 1, I doubled. Something's not right here. Where'd I go?
It's your cups is messed up.
Yep. So 1 gallon, 18 cups, or 8 cups. If I double it, I get 16 cups here. Right? The ounces are wrong. What'd I do? 32 is 4 cups. 8 cups is not 16 ounces. I don't know why I wrote that there. We got this.
1/2 cup.
32 ounces can fill 4 cups. So times 2 times 2.
If a gallon of milk is
64.
8 cups and a half would be 4.
I did divide by 2 there for some reason. But follow me with this table. It's a good table still. And to get from 8 to 16, what would I need to do to my 164? Double it to get to 128. So we know that 1 gallon is 128 ounces once we fix our table. I divided by 2 and I should have multiplied by 2 there. Which is fine. Shh. So, how do I get from gallons? How do I get ounces from gallons? So I'm going to put F for fluid ounces. For each gallon, how many ounces do I get? For each gallon, how many ounces do I get? 128. So if I take 128 and multiply it by my gallons, I will get my ounces every time. So 4 gallons, 4 times 128. 2 gallons, 2 times 128. A gallon and a half times 128. I like this 3-column table, though. I suggest you try that out if there's an opportunity.